Every few months, a headline pops up claiming that NASA has found Earth 2.0, a perfect, habitable world just waiting for us out there. But how much truth is there to these claims? Are we actually finding Earth-like planets, or is it all just overhyped speculation? In this video, we'll take a deep dive into the reality of habitable exoplanets, debunk some common misconceptions, and explore what it really takes for a planet to support life. There's a lot of astronomy misinformation online today. Between misleading articles, exaggerated claims, it's really hard to separate fact from fiction. Many planets that people believe exist simply don't, like J1407b, which was debunked years ago. Yet, videos and articles continue to claim it's an exoplanet with Saturn-like rings. And that's why I made this video, to help cut through some of that noise and bring you the actual science. So in this video, I'll be breaking down some of the most talked about habitable exoplanets and explain why most of them probably aren't as promising as they seem. One of the biggest misconceptions about exoplanets is the term habitable zone. This is the region around a star where temperatures could, in theory, allow for liquid water on a planet's surface. But that doesn't mean that the planet's actually habitable. For a planet to be truly Earth-like, it needs to be much more than just the right temperature. It needs a stable atmosphere, a magnetic field to protect it from radiation, and a surface that's capable of sustaining water. And most exoplanets we found in the habitable zone lack one or more of these crucial factors, making them far less Earth-like than headlines suggest. So with that, let's take a look at some of the most famous Earth-like exoplanets and see if they really live up to the hype. Kepler 22b was one of the first exoplanets to be called potentially habitable. It orbits in the habitable zone of its star, meaning that temperatures could allow for liquid water, but here's the catch. Its radius is 2.3 times larger than Earth's, and its mass is likely much greater. This strongly suggests that it's not a rocky world at all, but probably more like a mini Neptune, an ice giant with a thick hydrogen atmosphere. Even if it has water, that doesn't mean that it's habitable. Its extreme pressure and lack of a solid surface make it more like Neptune than Earth. The idea of an ocean world is exciting, but without any volcanic activity or hydrothermal vents, it's unlikely that life could even start there. Kepler 186f is closer to an Earth-sized planet, which makes it a more promising candidate. However, it's likely extremely cold with an estimated equilibrium temperature of around -85 degrees Celsius, which is -120 Fahrenheit, and that is much colder than Mars. So while a thick atmosphere could warm it up, it would have to be just the right balance, so not too thick or thin. Otherwise, it would end up as an icy wasteland, or if too much greenhouse effect kicks in, another Venus. So right now, we simply don't really have enough data to know. Proxima Centauri b is one of the most famous so-called habitable exoplanets because it's the closest exoplanet to Earth. But there's a huge problem. It orbits a red dwarf star that emits intense solar flares, and these flares can strip away atmosphere, sterilizing the planet's surface. Even if Proxima b ever had an atmosphere, it was likely blasted away long ago. With its star bombarding it with radiation and its probable tidal locking, meaning one side is always facing the star, it's more likely to be a barren, airless rock than a habitable paradise. The TRAPPIST-1 system is one of the most intriguing discoveries of the past decade. It has 7 Earth-sized planets, 3 of which are in the habitable zone. But then again, we run into the same problem. These planets orbit a red dwarf star, which likely flared aggressively in its early years, and recent observations from the James Webb Space Telescope suggest that some of those planets, including those in the habitable zone, might have already lost their atmospheres. And without an atmosphere, even an Earth-sized planet is just a lifeless rock. Despite all these challenges though, there is one exoplanet that stands out as a real candidate for habitability, and that is TOI 700d. Unlike many of the planets we've discussed, TOI 700d has a few major advantages. It orbits a relatively quiet red dwarf, meaning it hasn't been subjected to as much radiation. It also receives nearly the same amount of energy from its star as the Earth does from the Sun. It's also large enough to likely hold onto an atmosphere, but not so large that it turns into a mini Neptune. Of course, we still need more data, but out of all the so-called habitable exoplanets, TOI 700d has the best chances of actually being an Earth-like world. The search for Earth 2.0 is still ongoing. Right now, most of the habitable exoplanets we found are either too large, too cold, or too close to deadly stars, or they're missing crucial elements like a stable atmosphere. But that doesn't mean that habitable exoplanets don't exist. It just means we haven't found the right one yet. As technology advances, upcoming telescopes like the Habitable Worlds Observatory and future interstellar missions may finally uncover a true Earth-like planet. Until then, be skeptical of sensational headlines. True habitability is much more complex than just being in the right zone. Thanks for watching. If you enjoyed this video, be sure to like and subscribe for more deep dives into exoplanets, space, and the search for life beyond Earth. See you on the next one.